And here is the final version. First, let's create a new Rust project with the command cargo new Flappy bird. Let's open this project in VS Code. First, let's create the folder structure. I'm going to have two essential modules in this project. One is core and the other one is plugins. Core is where you have all the global elements that are going to be shared across the project, like components, resources, events, states, and whatnot. So all those things that are common across plugins, they will go into the core module. And inside the plugin, we're going to have different plugins that are going to handle different functionalities within this project. Okay. I went ahead and created all the individual files within the core plugin. So we're going to have constants, components, events, and all the different elements of a Bevy app. And in the mod file, I'm going to export all these. You can see all these files are empty for now. These files are going to get populated as we keep adding functionality. And inside the plugins folder, for now, I just created the shared plugin, which is obviously going to have all the shared components and shared events and resources that will export out of this module. And I'm also exporting all the plugins from here. And I'm going to use public. I'm going to export all the plugins this way so that I don't have to drill down into plugins in order to access different plugins. So again, I made a detailed video on how to create modules. You can check it out on the channel. Let's go ahead and create a simple Bevy app. Before we do that, we need to install Bevy and another crate that I use in the project. So the first one is, you can add crates with the command cargo add. The first crate that I want to add is obviously Bevy. And I'm going to add version 0.15 because that's the one I'm comfortable working with. The other one is rand crate, which allows you to generate a random value, and I'm going to pick version 0.8. Let's hit enter to install these crates. Alright, these two crates are installed. Let's clear the terminal. Let's close this window and let's go ahead and create a basic Bevy app in the main.rs file. To set up a basic Bevy app, I need a few constants. So I'm going to define those in the constants module. The first one is window title, which is going to be the title of this game, and window height and width. The window is going to be a static and we're going to disable resizing. In the main.rs file, I'm going to first import all the items from the Bevy crate, and then I'm going to define the core and plugins module and import everything inside these two modules. So defining it this way allows all the child modules to access constants or components, or all these things by, with the clause use crate :, and whatever is being exported by these two modules. Alright, then we're going to create a new app, and inside the new app, we're going to define a single primary window. And inside this window, we're going to set the title to Flappy Bird and set the resolution to Windows width and height, the values that we just defined. And we're going to disable resizing. And then we're just going to run the app. Let's hit save and let's run this. You can run it with the command cargo run, but I prefer to create scripts so that if you want to add any prefix, for example, if you want to have different logs for development and production, you can set the prefix Rust log. Having dedicated scripts makes your development process easier. So I created a scripts folder with 3 different scripts, one to run in dev mode with Rust log info. Again, I covered these in detail in my earlier video where I showed how to create snake using Bevy. So I'm not repeating myself over here. To run the app, I'm going to use the script run dev. Hit enter. The first time you run it, it's going to take a while to compile. Perfect. That took a while to run, but finally we can see the window pop up. Let's close this. It took almost 52 seconds to run, but like I said, the subsequent runs should be much faster. Let's clear this. Now I want to set a background color for this window. Before we go to the next step, let's commit these changes. The background color is going to be static, so I'm going to put this in the constants module. Let's save this. Now let's set the background color in the shared plugin. So first I'm going to import everything from the Bevy crate. And I'm also going to import everything from the core module. Then you can create, this is how you create a plugin. So create a struct called shared plugin, and then you implement plugin trait for that shared plugin. And inside that trait, you're going to implement the build function for the plugin. So that's how you create a plugin. And then we can insert a resource to set the background color. We can insert the clear color resource, which Bevy sets as the default background color. So inside the color, I'm just going to pass the background color that we defined in the constants. Let's save this. Inside the main.rs file, I'm going to add plugins and add the new shared plugin that we just created. And because we're already importing everything from the plugins module, you don't have to import each and every individual plugin from here. So this makes importing and exporting modules really simple. Let's save this. Now when we run it, we should see the background set to sky blue color. Awesome. So this works. Let's commit these changes and move on to the next chapter. In this chapter, we're going to plot the bird. So I downloaded two assets. One of them is the bird and the other one is the pipe. These are individual sprites. If you look at the properties of these sprites, you can see the bird is of dimension 12 pixels by 8 pixels and pipe is of size 18 pixels by 144 pixels. So the reason we choose to go with sprites is because sprites boil down an image into its most fundamental unit. So we just plot each individual pixel and then we scale it as required. That way, when you load these sprites in the game, they are performant because you are boiling the image down to its the smallest pixel, right? The most fundamental unit. Then I created a new plugin called bird, and I'm just going to define an empty plugin, and I'm going to export this from the mod file and also include this plugin in the main.rs file. Okay. Before we plot the bird, we need to first load these two sprites. So we're going to do this in the shared module. So first I have to create a resource to store these two sprites. So I'm going to call these texture assets. So I'm going to call these two sprites as textures. So I'm going to create a resource called texture assets, and inside that we're going to have a texture for bird and another one for pipe. Let's close this. Then in the shared module, I'm going to add a system that's going to run on startup to load the textures. So we're just going to load from bird.png because these two are inside the assets folder, so we can directly call them and then insert these two textures. Let's save this. To plot the bird, I'm going to add a new system in the birds module that's going to run on startup. I'm going to call it spawn bird, and inside the spawn bird, I'm going to first check if the textures are loaded. If not, just return it and then spawn the bird. I also want to create this dummy component called bird so that I can query the bird component easily later. So let's go ahead and create that in the components module. That's it. I also need to define a few constants, or I should say properties of the bird. So let's define those in the constants module. So here are the few properties of the bird. Bird start x and start y define the starting x and y coordinates. Then we have the scale 2.5. So we scale the bird 2.5 times on the x and y dimensions. And then we have the bird width and bird height. So when we looked at the image, right, these are the properties of the sprite. The width is 12 pixels and the height is 8 pixels. Okay. Let's go ahead and run this. When we run this, we don't see anything because we haven't spawned the camera module. So let's go ahead and create a camera module and spawn it. So inside the plugins, I created the camera module where I'm just going to spawn the camera on startup. I'm going to export this from the plugins and also add it to the main.rs file at the beginning. Let's save this. Let's run it again. We still don't see anything. I understand what's happening, but I want to replicate the issue first before I provide the solution, so that you understand why we need that concept. So the reason we're not able to see the bird is because if you look at the birds plugin, we are running the spawn bird on startup. All right. And if you look at the shared plugin, we're also running the load textures on startup. So generally these systems, they run in parallel unless you provide some kind of sequence. So right now, because both of these run on startup, it's quite likely that if the textures are not loaded immediately, then in the spawn bird system, we are first looking if the textures are loaded. So I'm quite sure that when this piece of code runs, it's not able to find the textures and we're just exiting the systems, which is the reason why the bird is not spawned. So the best way I found to fix this is to introduce game states. Now you can add a sequence, but game states allow you to transition between different high level states, and they also keep the game performant. So let's define a game state, and we're going to have different states. And first we're going to start with the loading stage, and during the loading stage we're going to load the textures, and then we're going to transition from the loading state to running state. And in the running state we're going to run the spawn bird. When the game enters into the running stage, we're going to run the spawn bird system. That way we can be assured that the textures are loaded before we spawn the bird. So inside the states module, I'm going to create a new state called game state. It's going to have 3 values: loading, where we'll load the assets, then it's going to be playing, and finally when the game ends, it's going to be game over. Okay, and the default value is going to be loading. Let's save this. Inside the shared plugin, instead of providing a startup schedule, we're going to provide on enter game loading. So what this does is, whenever the game enters the loading stage, which is when we first run the game, the load texture is going to run, and this is only going to run once when the game enters into the loading state. Okay, we also need to insert this game state in this app, so let's also do that in the shared plugin. I'm going to add the state at the top with the clause init state. Then inside the load textures, I'm going to import this state, and after loading the textures, I'm going to set the next state to playing. Now let's go back to the bird plugin, and here instead of startup, we'll change the schedule to on enter game playing. So this is only going to run once when the game enters into the playing stage. So that way you understand how this works, right? So by doing it this way, first we are ensuring that the textures are loaded, and only after that we are able to spawn the game. Okay, let's save this and let's run this. Awesome, so you can finally see the bird. Let's close this window. Let's commit these changes and move on to the next chapter. In this chapter, let's go ahead and handle the mechanics of the bird. So the way this works, I'm sure you must have played Flappy Bird before. So the way this works is, by default, the bird is pulled downwards by gravity, and every time we hit the key, I'm going to use space bar to handle the movement. So every time I hit the space bar, the bird is going to jump, and that's way that flaps the wing and keeps the bird afloat. Okay, so we use the space bar to fight against the gravity. So let's go ahead and implement this functionality. So I'm going to need a few constants. The first one is gravity, the gravity with which the bird is pulled towards the bottom of the window. And then I'm going to have flap impulse. So every time I hit the space bar, I'm going to update the velocity by this much. Okay, and then I'm going to have terminal velocity. So terminal velocity is the least velocity that the bird can have. So if the velocity goes beyond this value due to gravity, it's going to be clamped at -480. This is just to prevent infinite acceleration. Okay, let's save this. Inside the components module, I'm going to create a new component to store the velocity. In the case of bird, we're only going to have velocity in the y direction, because the bird on x-axis, the bird is going to say static. But later we're going to implement velocity on pipes as well. So pipes are going to have x velocity but not y velocity. So we're going to handle velocity for both pipes and bird in this velocity component. So I'm going to create this struct with a vec2. So vec2 handles both the x and y velocity. Okay, so inside the birds plugin, I'm going to add the velocity when I spawn the bird. And again, the bird by default, when we spawn it, it's going to have velocity 0 on x and y direction. The bird is only going to get velocity through gravity or when we hit the space bar. So first let's implement gravity. So I'm going to add a system that runs on update, and I'm going to call apply gravity, and it's going to run only when the game is in playing state. Okay, and then let's go ahead and implement that system where we just update the y velocity with the bird gravity, and we're going to clamp it at the threshold velocity. Let's save this. Note that we are only changing the velocity component, but it's not going to reflect on the bird. The bird is not going to move because we are still need to manipulate the coordinates of the bird. And I'm going to create a new plugin to handle the coordinates, to move the x and y coordinates, because like I said, the velocity, component is going to be applicable for both the bird and the pipe. So I'm going to create a separate plugin where we handle the entire movement based on the velocity for both the bird and the pipes. and also handle collisions. There are some systems that I believe are related to both bird and the pipe, which I want to handle in the game state plugin. So I created a new plugin called gameplay, and inside this new plugin, I'm going to add a system called translate with velocity, which is only going to run when the game is in playing state. And then we're going to apply both the x and y velocity on the transform. So once we implement this function, the bird is going to move. And this system is going to be useful later when we implement the pipe functionality as well. Let's save this. Now when we run the game, you can see that the bird falls towards the bottom side of the window due to gravity. Now let's go ahead and implement controls plugin, where every time we hit the space bar, the bird is going to jump and gain upward momentum. So inside this controls plugin, I'm going to create a system that runs on update schedule and only when the game state is in playing state. And I'm going to create a system called send flap event. So every time we hit the space bar, we trigger this flap event. Okay. This event doesn't exist right now, so let's go ahead and create that. Alright, once we create the flap event, let's go ahead and insert that resource in the shared plugin. Alright, this is how we insert the event. Now if you go back to the controls plugin, that error should disappear. Let's save this. We are triggering this flap event, but we are not updating the velocity. Let's go ahead and update the velocity in the bird plugin. Inside the bird plugin, I'm going to create a new system called set bird velocity on flap. And in the system, I'm going to listen to the flap event, and every time a new event is received, we're going to set the bird velocity, the y velocity, to the bird flap impulse that we declared in the constants module. Let's save this. Now if we run it, awesome. Every time we hit the space bar, the bird gains upward momentum. So that's how we control the bird. Let's commit these changes and move on to the next chapter. Now let's go ahead and implement pipes. So we're going to spawn a pipe on the right edge of the window, and we're going to move those pipes towards the left edge at a constant velocity. I'm going to need a few properties to implement this. So here are the list of properties related to pipe. The first is pipe speed. So we're going to move the pipe at 180 pixels every second. And we're going to spawn a new pipe this is in milliseconds. So every 1500 milliseconds, that's around 1.5 seconds. And then we're going to have pipe gap. So we're going to spawn a pair of pipes, and there's going to be a little gap between the pipes for the bird to move. And this gap can be at a random location, but the width is always going to be 180 pixels. Okay. Again, we can keep it dynamic, but to keep the implementation simple, I'm going to have a static gap between the two pipes. Then we have the pipe width and height, which we get from the properties of the pipe asset. Then we're going to scale the width and height by size 2, so that's the pipe scale. And then we have a minimum threshold for where the gap can start from. So we're going to put it as 32 pixels from the bottom. So the pipe cannot, so we don't want the gap to start from the top or the bottom of the window, right? So we want to have some padding. So that's what this does. So we're going to have 32 pixel padding so that the gap doesn't start at the bottom or at the top. So I'm going to create a new plugin to handle pipes, and I'm going to export this from the mod file and also include the pipes plugin in the main.rs file. Inside the pipes plugin, I'm going to add a new system that's going to run once every interval, right? We defined the pipe spawn interval as 1.5 seconds. So we're going to run this system once every 1.5 seconds. And we're only going to run this when the game is in playing state. Okay. And inside this, we're going to spawn a new pipe. Here is the math for identifying the coordinates of the pipe. Again, we're going to spawn two pipes, one at the top, an inverted pipe at the top, and one at the bottom, and we're going to spawn it at the right edge of the window. Again, you can take a look at the math. I'm not going to spend too much time explaining this. Then we're going to spawn two pipes, first one at the top, the other one at the bottom. Okay. Now we need a couple of things to make it work. First is an empty pipe component I added this component to be able to query it later, to be able to easily query it later. So we're going to create this dummy component. And then I also need this global range to be able to generate a random value, between, to spawn the gap. Okay. So first in the components module, I'm going to create a new empty pipe component. Inside the resource module, let's go ahead and create the global range resource, implement the default trait, and also import the required items from the random crate. Let's save this. Let's initialize this resource in the shared module, shared plugin. Now if we go back to the pipes plugin, you should see the error disappear. So we are also going to add a velocity component for these pipes, and you can see the velocity is minus of pipe speed. So we're going to move in the constants module, we define the pipe speed as 180 pixels. So we're going to move it from the right edge to the left edge. So that's why we set the value as negative pipe speed, and the pipes are not going to have pipe velocity. So we're going to set it to 0, and we are already translating the coordinates inside the gameplay plugin, right? So this translate with velocity is going to now work for both bird and also for the pipes. So let's run the game and see that in action. Awesome. So as you can see, the pipes are spawning on the right edge and moving towards the left edge, and you can see the gap is constant, but the gap is spawning at random locations. And yeah, the bird is hitting the pipes, nothing happens. We need collision detection and few other functionalities to implement, but so far it looks good. Let's close this. Now we need to clean up obsolete pipes. So as we play the game, the pipes spawn on the right edge and move towards the left edge, but they're still kept in memory. If we don't delete them, they're going to stay in the memory, and we're going to end up having infinite number of pipes, which we don't want. So we're going to clean up all obsolete pipes. So inside the pipes plugin, let's add a new system that runs when the game state is in playing mode, and we're going to call it clean up obsolete pipes. Inside this system, every time the pipe x coordinate crosses the left edge of the window, we're going to despawn this. We don't have this constant defined, so let's go ahead and create that. So for now, let's just set the value to 100 pixels to show you how this works. So now every time the pipe crosses the 100th mark, remember the axis starts at the center of the window. So every time the pipe crosses the 100 pixel, it's going to disappear. You see, as soon as it hits the 100 pixel mark, it disappears. But in reality, this is not what we want, right? We want the pipe to disappear when it hits the left side of the window. So the left side of the window is going to be half the window width. So I'm going to set this value correctly. Now if you run it, awesome. So as soon as the pipe crosses the left edge, it is perfect. Let's commit these changes and move on to the next chapter. In this chapter, let's display the score. So I'm going to create a new plugin called a UI, where we're going to display the score and also a banner when the game ends. I've exported this plugin from the module and also included that in the main.rs file. Okay. So I'm going to create a system where we're going to run at startup. And in this system, I'm going to display the score, both the current score and the highest score. And I'm also going to display the banner. I'm just creating all the entities to display both the score and the banner. We need to create a few components that will do it after we finish with this plugin. Then, once we add the system on startup, we're going to create a new system called sync score text, where every time the score is changed, we're going to show the current score. So the good thing about Bevy is it offers this function called isChanged. So every time a resource is changed, we can query that and update the score accordingly. Okay. Then let's include that system on update in the plugin. Then we're going to include these two banners. So we're going to control the visibility of the banner. So whenever the game ends, we're going to make it visible, and when the game is running, we're going to make it hidden. Okay. And let's also include these systems in the plugin. Let's save this. Now let's go ahead and create these resources and also components. So first I'm going to create score resource, which is going to hold the current and the highest score. Inside the shared plugin, I'm going to insert that resource. Now we need to create score text and game over banner. So if you go to components, and I'm going to create score text and game over banner. Let's save this. Now when we run the game, we should see the score on the top left corner. We can see the score, but we still need to implement updating the score. So every time the bird crosses a pipe, we need to update the score. So let's go ahead and implement it. So inside the gameplay plugin, I'm going to add a new system called track score. Inside the system, we're going to query for the transform component to get the x coordinate, and we're going to look at the x coordinate of the bird and the pipe and check whether the bird has crossed the pipe. Okay, and that's what we're going to do in this for loop. And if the score flag is true, we're going to update the current score and high score. Let's save this. Let's run this game. You will see a weird anomaly now. So as soon as the bird crosses the pipe, see the score is increasing not by one but many folds. The reason this is happening is because we are running the track score system on the update schedule. So this is going to run on each and every frame. Even after the bird crosses a particular pipe, stay alive in memory until it crosses the left edge of the window, right? If you look at the pipes plugin, we are cleaning obsolete pipes only when it crosses the left edge of the window. So during this time, when the bird crosses the pipe and the pipe reaches the left edge of the window, the system keeps calling, the track score system keeps calling again and again, and it's going to increment score multiple times for the same pipe, which we want to avoid. So we can avoid this by adding a new empty component when we spawn the pipes. So when we spawn the pipes, we can add a new empty component called pipe track, and in the gameplay track score system, we're going to query with this pipe track, and every time the bird crosses a particular pipe, we're going to remove this component. That way, when the system runs, we are only querying for the pipes that are not yet crossed. Okay, so let's first go ahead and create this component. After we create this component, we no longer see that error in the pipes plugin. Now let's go back to track score. Here in the pipe query, instead of with pipe, we're going to have a with pipe and also with pipe track. Okay, and then if for a particular pipe, if the score flag is true, we're going to remove the pipe track. We're going to drop that component for that particular pipe. Okay, that's it. Let's save. Now the score should look good. Let's see. Awesome. So now the score is only incrementing by 1. Let's commit these changes and move on to the next chapter. In this chapter, let's implement collision detection. So every time the bird hits the pipe or reaches below a certain y coordinate, we're going to terminate the game. So inside the gameplay plugin, I'm going to add a new system called collision detection. Inside this system, I'm going to query for the bird coordinates and also for the pipe coordinates. And then if a collision is detected, I'm going to change the game state from playing to game over. Okay, so let's query the positions, and if the collision is detected, we're going to set the game state to game over. And even if the pipe reaches below the gap, we're going to set it to game over. Okay, let's run it. Let's cross a few pipes and then see if the collision. Awesome. So as soon as the bird hits the pipe, we see this banner which we set in the UI plugin. It says game over. It also says press space to restart, but we haven't implemented that functionality yet. So as soon as the game ends, when we hit the space bar, the game should reset and start all over again. So let's do that in the next chapter. Let's commit these changes first. So inside the controls plugin, I'm going to add a new system that is going to run when the game is in state game over. I'm going to call it send restart event. And whenever I hit the space bar in the system, whenever I hit the space bar, I'm going to trigger this restart event. Let's create this event first and declare that in the shared plugin. Inside the events module, I'm going to create this new event. And if we go to the shared plugin, let's initialize this event. That's it. After initializing this event, if we go back to the controls plugin, the error should no longer exist. Now in the gameplay plugin, we're going to listen to the restart event and reset the game. inside the gameplay plugin, I'm going to add a new system that runs on update. I'm going to call it game reset, and it's only going to run when the game is in straight game over. Okay. And inside the system, I'm going to delete everything, delete the bird, delete all the pipes, and set the next state to game playing. So as soon as we set the game state to playing, if you look at the bird plugin, right, we are running spawn bird as soon as the game changes to playing state, right? So let's see this in action. Let's cross a few pipes and hit the collision. So the game ended. If we hit the space bar, the game should start all over again. The only thing that should remain static is the highest score. Let's see if that works as expected. Awesome. So except high score, everything else got reset. And let's see if the high score increases if we cross the 4th pipe. Awesome. And let's hit again. Game over. And if we restart the game, perfect. So everything works as expected. Let's commit these changes and move on to the next chapter. In this chapter, let's add a few final things before we push this project to GitHub. So I created a UML diagram that represents all the states and how different systems interact with one another, and it gives you a bird's eye view as to everything that's happening in the project. So you can preview the file and see how the game runs. I also created a readme file and also the license file, which is just MID open source license. And that's it. So that is how you create Flappy Bird using Bevy. I didn't include unit testing or integration testing like I did in the previous video because I want to keep this short, but if you want, you can go ahead and include those too. That's it for this video, and I'll talk to you in the next one. Bye.